Confidential computing is a relatively new term, and what it means really is protecting data and code in use using hardware-based trusted execution environment. It's the hardware, which could be your CPU, like Intel or AMD CPU or ARM CPUs, which provide a secure region in the memory where data comes in, and any data or code that goes inside the secure environment stays isolated. You get integrity protection of the compute and the data that goes inside that secure environment.
They were the words of the CEO and co-founder of Fortanix. And I think recently the competitive landscape of AI has shifted somewhat. It's no longer just about algorithms, but the fuel that powers them, which is data, which creates a dilemma of sorts, balancing innovation with data privacy and compliance, particularly in a world increasingly scrutinised by GDPR and similar regulations. So today, I want to dive deep into this compelling frontier with today's guests, and also demystify a phrase I'm hearing very often at the moment, and that is confidential computing, a technology that could very well become the gold standard for data security in this era of AI. So today we're going to bust some myths, explore the challenges, and look at why confidential computing is becoming the de facto form of computing. So buckle up and hold on tight, because I'm going to beam your ears all the way to California, where the CEO and co-founder of Fortanix is waiting to join us today. So a massive warm welcome to the show. Can you tell everyone listening a little about who you are and what you do?
Hi, my name is Anand Kashyap. I'm co-founder and CEO of Fortanix. Fortanix is a data security company. We started about 7 years ago.
Well, it's a huge pleasure to have you on the podcast today. So much I want to talk about with you today. And one of the things, of course, is the data paradigm within AI, because AI models are now a commodity, and it's the data that gives companies a competitive edge. So to set the scene for our conversation today, can you elaborate on how you assist companies in not just safeguarding data, but also leveraging it responsibly for AI, because it's such a huge topic right now, isn't it?
Absolutely. Data is the most important thing when we talk about AI. There are a handful of companies which are building foundational models. Everybody else is either improving them or just using them. And then they're using it with their own data. They're using it with public data. They're using it with their customers' data in some case. And then they're generating new data with generative AI. And as companies are doing it, they have to think about a lot of things. How do you keep that data private? How do you keep that data secure so that there's no leakage of data, unwanted leakage? Then they need to care about compliance, especially in places like Europe with GDPR. You need to have consent before you use your customers' data. You need to have right to be forgotten. If somebody gives you their data and then you've trained an AI model or maybe generated new data with that, the data which was given to you, and now somebody says, okay, delete all my data. How do you do that if you don't know where the data has gone, in what state that data lives? Where we come in at Fortanix is we provide a data security platform that can provide an end-to-end security platform. So first, we can help you discover sensitive data, find sensitive data, then secure that data using technologies like encryption, key management, tokenization, which is taking a piece of data and converting it into the same format but encrypted. And then we can allow this data to become useful using something called confidential computing. This is where we can process data, and this could not just be your own data, but maybe it's a mix of data from multiple parties. So imagine multiple parties which don't trust each other, but they want to share the data so that they can train a model or do some inference on the combined data. But being able to do that in a very secure environment using confidential computing, that is something we enable as well.
And of course, you mentioned keeping data private and secure, and that is paving the way for the term that we're hearing more and more now, and that is confidential computing. And it's gaining traction, but it does remain elusive for many. So I'm curious, how would you define it in layman's terms? And can you give me a snapshot of its evolutionary trajectory over the last 5 years? Because it does seem to be building momentum.
Absolutely. Computational computing is a relatively new term in security. And what it means really is protecting data and code in use using hardware-based trusted execution environment. So essentially, it's the hardware, which could be your CPU, like Intel or AMD CPU or ARM CPUs, which provide a secure region in the memory where data comes in, and any data or code that goes inside the secure environment stays isolated. You get integrity protection of the compute and the data that goes inside that secure environment. Recently, NVIDIA has announced something called computational GPUs, which will allow training and inference to be done in a secure environment as well. If you look at the history of evolution of hardware-based security, and there were things like TPM, which are still heavily used. Then Intel had come up with something called Trusted Execution, TXT. But what TPM, TXT, what they did was provided a way to do secure boot. They would do integrity checks on what is being booted. And they were essentially useful for boot time integrity protection. What technologies like Intel SGX and AMD SCV and AWS something called Nitro, what they provide is a broader basis for computational computing, which is not just about boot time integrity, but also runtime protection of any data and code that goes inside that secure hardware-based trusted execution environment. And that is essentially what has become computational computing, and the cloud providers have embraced it now over the last few years. Azure, Google, and AWS, they all have their own offerings, which are VM-based or container-based, and then they're also building services on top to expose computational computing as infrastructure as a service or platform as a service. And then software vendors like Fortanix come in on top, and we are building orchestration systems where you can run workload inside a computational computing environment where you can do encryption, protect the keys, and enable use cases like multi-party compute, securing AI at runtime, all of this using computational computing.
And you did mention a few moments ago regulation, and regulations like GDPR here in the EU is focusing on erasing an individual's data upon request. And of course, that poses a unique challenge for AI models that have been trained on that data. It's a real mind bender in a way. So how do you approach this dilemma to ensure compliance without compromising the integrity of the model? Because it sounds incredibly complex.
And this is where confidential computing shines as well as a good way to secure the data using encryption, anonymization, and things and protecting the keys. What we do at Fortanix is our philosophy is data should stay encrypted as long as possible. So encrypt the data as close to source when the data is generated, and then manage the keys and the access control on the keys such that only the right people, the right machine, the right application have access to those keys. And this is where the core integrity, when you're doing AI, when you're running a model inside confidential computing, you can attest remotely that it's the right model that is being used, it's the right code that is being run, and only then allow access to the data to that application. And by enabling this end-to-end encryption of data, making the encryption keys only available to the right entity, and ensuring all of that, the integrity of all of that using confidential computing, that forms the basis of securing this data, and also compliance. Because if somebody says delete all my data using the right to be forgotten clause, then an enterprise should be able to first of all trace where the data is. And this can be possible because if the data is encrypted using a key and you know who has access to those keys, all you need to do is just disable that key. So now there's no plain text data available anywhere else.
Confidential.
New data has been created. Then again, if you have encrypted it using the same key, then all you need to do is disable that key.
And you've also mentioned that confidential computing is becoming the de facto form of computing. So can you tell me a little bit more about the factors that are contributing to this shift, and also what it's implying for businesses across multiple industries?
Yeah, so if you remember in the 90s or early 2000s, a newer technology had come in the web called SSL, which is now called TLS. And then there was an effort from multiple companies to convert their websites to support TLS and go from an HTTP version of the website to HTTPS. And in the beginning, only the sites which had some sensitive content were being used for HTTPS or maybe e-commerce sites. But if you look at what's happening now, you will hardly find a website which still only supports HTTP. Almost everything has transformed into HTTPS. And this is because it's just a more secure way of doing communication. Now, coming back to compute, with confidential computing becoming readily available from the chip vendors, from the cloud providers, from the server manufacturers, in future, there won't be a reason for not using confidential computing when you can. So whether you're running an application, a database, a compute system, anything that runs on a CPU, why would you not use confidential computing if it is easy to use? And that's the key. The ease of use needs to be there. And that has been a challenge in the last 5-7 years in which confidential computing has been available. But with the recent advancements in providing VM-based confidential computing or making it easy to run a container with minimal changes in a Kubernetes environment using confidential computing, I think very soon we'll be at a state where any application that you're running in a normal non-confidential computing-based infrastructure, you should just be able to run it in a confidential computing-based infrastructure. And then there'll be questions around how do you manage trust? Because with confidential computing, just like with HTTP and HTTPS, the problem became how do you manage certificates that these websites have? How do you renew certificates? How do you revoke certificates? Things like that. Now, with confidential computing, the first wave will be just using confidential computing environment, but then it will be about how do you manage attestation? How do you manage the trust around those attestations? How do you manage the certificates related to those attestations? And then how do you enable the right application has access to the right data?
And one of the things I try to do on this Daily Tech podcast is bust a few myths and misconceptions that may surround technology, all the latest buzzwords. And there are several myths around what confidential computing can and cannot do. So just to clarify here, can you clarify some of the most common misconceptions and just set the record straight once and for all?
Yeah, absolutely. I think there are two camps of people who don't understand confidential computing really well. There's one camp which often tends to overstate the capabilities of confidential computing. And then there's the other camp which understates the capabilities of confidential computing. Now, if you think about the people who overstate the powers and the capabilities of confidential computing, they think, once you have confidential computing, you don't need any other security tool. Everything is secure. But that's not the case. Confidential computing just enables an application to be secure at runtime. But if your application is poorly written, then it will be poorly written even when it's running inside a confidential computing environment. So if there is a bug, if there's a vulnerability, if your application just tries to exfiltrate all your data, it will still do that in a confidential computing environment. So you still need to write your applications correctly and fix all the vulnerabilities, even if you're using confidential computing. That part doesn't go away. And then on the other side, confidential computing is often confused with several other technologies which are under various stages of maturity, which allow you to compute on encrypted data. So there are technologies like fully homomorphic encryption, The technologies like differential privacy, multi-party compute, the people using synthetic data to train AI and things like that. Where computational computing compares with all these other technologies is that it's probably the most practical and the most performant technology right now. There are things like fully homomorphic encryption, which claim to be able to do any compute on data without ever decrypting that data. But then you can only do a few things with that data right now. You can't run a machine learning model on the data, for example. It will take years or decades to do something which can be done in microseconds or milliseconds using computational computing. The performance arbitrage is huge. So compared to the other technologies, computational computing is very powerful when dealing with secure data, sensitive data, which needs to stay encrypted as long as possible. So that's on the side where people often confuse this with the other technologies.
And while data privacy regulations might be more stringent here in the EU, I'm curious, how are you adapting your solutions for markets with these varying levels of data protection laws, such as the US or emerging economies? Because it's only going to increase, isn't it, in the years and months ahead, I suspect.
Yeah, and we're already seeing that. So I think GDPR, when it came in about 2017, it laid the benchmark of how data privacy laws should be and what they should aim to achieve. What we have seen is a lot of other regulations in various other countries around the world, which have similar clauses as GDPR. In the US, we don't have a federal data privacy law, but different states have come up with their own regulation. California has something called CCPA. New York has its own data privacy law now. Other countries like India, for example, they just passed a new data privacy law, which requires protection of data for the Indian citizens. What we're seeing essentially is there are requirements for consent of data being used, things like right to be forgotten. But then there are other things as well, like data sovereignty as becoming a big requirement in many places. And what that also means is that in various places, if you're a company like Facebook, for example, or Meta, and you operate a network at a global scale, now, because of the data sovereignty requirements, you will have to start fragmenting your infrastructure to address various data sovereignty laws. If for European citizens, you can't take the data out of Europe, then you need to have data centers in Europe. Similarly, even for us, we need to address these requirements as well. When we run our global SaaS, we actually create multiple different regions, one for Europe, one for US, one for UK, and such, so that the encryption keys which are created in a region, they stay in that region and they don't go to other regions. We're also seeing that big cloud providers are setting up sovereign clouds infrastructure in various countries. And this is to further address the public sector requirements and governments which don't want to share their data outside their country, for example. Even with GDPR, even with EU, there are countries which want to keep their data inside their country. And we're seeing a lot of interest in setting up these sovereign cloud environments. And from Fortanix perspective, we are partnering with a lot of these efforts just to be the data security provider for this sovereign cloud efforts.
And as this tech landscape continues to evolve, it's moved at a tremendous speed this year, and we can expect more of the same in 2024, which is just a few months away. What are some of the challenges that you see confidential computing facing in staying ahead, and how are you preparing for these changes too?
I think some of the regulations around data privacy and security will continue to become more and more stringent going into 2024 and beyond. So the requirements for keeping the data private, keeping it in a sovereign region, I don't think that will go away. It will only keep getting more and more important. The one challenge that confidential computing has had so far is availability in the cloud, in the public cloud. But now that that is being addressed, all the major cloud providers have started offering confidential computing. One opportunity that I see for confidential computing specifically is creating a sovereign cloud zone inside the public cloud. So using confidential computing, if you can carve out or segment certain parts of the network and then create using policies, using configurations, and using attestation and confidential computing, if you can make sure that the data stays inside that network and it cannot go out, I think that can provide an increased level of security guarantees, which can help address some of the data security regulations that are coming. So, there is in a global world that we live in, there is a lot of localization and fragmentation of the global network that is happening. But hopefully with confidential computing, doing that can become easier and more efficient in future.
And if we dare to zoom out for just a moment and try to look and explore beyond just compliance, there is, of course, also an ethical dimension to data usage and protection. So how are you incorporating ethical considerations into your data protection strategies? Is there anything you're able to share around this too?
Yeah, so data privacy and security, it goes beyond just regulation. What we're saying is even in places which don't have strict regulation around data like GDPR, even in the US, there are certain sectors, like in healthcare, for example, where people are using confidential computing and technologies built by us to secure the data, to train AI models, and finding cures for diseases which require building certain models and processing data that typically would never be used for that purpose. And using confidential computing now, you can train your models or you can process the data while keeping the data still private. And that is quite powerful, and it goes beyond just a compliance requirement or a compliance check. It's about enabling completely new use cases. And that is something we have been working with companies in the US, in Southeast Asia, and Singapore. There's a company called Zulik Pharma, for example, where they have built a digital data exchange and bringing together data providers as well as data consumers. So this could be your clinics, individual users of the platform, pharma companies and such. They all come together to process the data, or they use the data, or take useful analysis from the data. And these are creating new ways to process data that was simply not possible in the past without confidential computing.
Completely agree with you. And if we look into the future, well, I think there's a real pressure on almost everybody and everybody listening to be in a state of almost continuous learning to try and keep up to speed and stay ahead of the tech trends. So I'm curious, where or how do you self-educate to try and stay ahead of the curve?
For me, I like to learn from other leaders in the field, other startup founders. I love listening to stories of how great companies were created and what went behind creating them. I listen to a lot of podcasts for that. Some of my favorite podcasts, there's one called Acquired.fm, and they go into a lot of detail and describe history and origin of iconic companies. So companies like Amazon or Nvidia and such. And I love listening to how those companies operated when they were at an early stage, and how the founders thought about the company and the business and the market and how they evolved over time. And learning from them, I try to get some useful nuggets that I can apply in my own life and in my own company as well.
Well, I've loved chatting with you today. And for anyone listening that would just like to dig a little bit deeper on some of the things we talked about, including confidential computing, where would you like to point everyone listening to find out more information, contact your team, etc.?
Yeah, if you go to our website, www.fortanix.com, you can find a ton of resources on all the things I spoke about confidential computing. There's a blog section where we have a number of blogs about how we enable various use cases using our product and how we work with other partners, the cloud providers as well, to enable various use cases. So I would send everyone to fortanix.com.
Well, I love chatting with you today, hearing more about your thoughts on what companies need to do to properly manage the privacy and compliance of data sets, confidential computing, what it is, what can it do, what can it not do, some of the misconceptions around that, and also why the technology is becoming the de facto form of computing. So much gold in your answers today, and I know there are going to be a lot of people reaching back out to you, but more than anything, just thank you for simplifying the world of confidential computing, putting it in a language everyone can understand. Really appreciate your time today.
Thank you, Neil. Thanks for having me.
So a big thank you to today's guest for shedding light on that crucial role of confidential computing and what it plays in securing our data-laden future. And I think the key takeaway for me was confidential computing is not a nice to have. It's an essential part of how companies can secure their data while maintaining compliance in this increasingly regulated world. And it is important to highlight too, though, I think, that it's not a silver bullet. Well-written applications and multi-layered security strategies remain vital. So data privacy regulations will continue to shape the technology landscape and will drive innovation in security solutions. But sovereign cloud zones and compliance mandates might sound like challenges, but for industry leaders like today's guest, they're opportunities to create a more secure, ethical and efficient computing environment. That's got to be a good thing, right? But as always, if you've got anything you want to add to today's conversation, if you want to join me on the show, whatever it is, please email me now, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just add Neil C. Hughes. My website is techblogwriter.co.uk, where you'll find 2,600 interviews. Yes, there's lots to keep you out of trouble. And if that's not enough, come and join me. Same time, same place tomorrow. We'll do it all again with a completely different topic. But thanks for listening today. And until next time, don't be a stranger.